Hello IT Pros, welcome back to my IT workshop. So in this last video of the series, we're going to be learning about variable length subnet masking or VLSM. If you haven't watched the previous videos, you can find them in the top right of this screen. So what is VLSM? So the concept is that we grab a big network and we're going to chunk it into small ones. And the difference from what we have been doing so far is that they are not fixed. What does this mean? That what we have been doing is let's say we need 5 networks, each one of 50 users or 20 users or whatever, but the number is the same of hosts. So in this one, we are going to use a real case, which means different networks might need different number of hosts. So for that end, I have designed a small network. These are 3 routers or 3 offices that can be located in different places of a city. And they are going to have different needs when talking about host. So for instance, one network is going to, they are going to have computers, they're going to have servers, they're going to have printers or any other thing. So the first network is going to be 61 users. The network, another network is going to be 53. And the last one, well, it's not the last one, and the other is going to need only 18 users. So you see that they have different needs. They are not the same. I want to ask you something. How many networks do you see in this diagram? If you know, pause the video and think. Okay, here we are. In this diagram, we have 6 networks. The first 3 and the ones in the middle, which are the links between offices. Okay, so each one of these small networks are going to need 2 IP addresses, each usable IP addresses. So the way we're going to do this, I'm going to show you a new trick. So instead of finding the equivalent in binary of these numbers, 71, 53, and 18, we're going to do something else. So I'm going to bring back the numbers that we learned in video number 1. And how many bits do I need to create number 71? What do you think? I need 32? No, I need more than that. I need 64? Yeah, what about 128? Well, that's too much. So I'm going to keep 64. So how many bits are till 64? 2, 4, 7. So to create number 71, I'm going to need at least 7 bits. Okay, if you don't understand how to do this, you can do it the old way, and you are going to find the same result, that we need 7 bits to create the number 71. So again, I need 7 bits, and now I'm going to do what we always do. I'm going to copy the default network mask in binary for a class C, which is the 3 first octets are going to be 1s and the rest 0s, and then I'm going to reserve 7 bits of host starting from left to right, which means 0s, and the rest are going to become 1s. With this, I can find my new network mask, which is going to be 255.255.255.128. With this, or /25. With this, I can find my increment, which happens to be in the 4th octet, and my increment is going to be 128. If I have this, all of this, I can find my network. 192.168.50.0/25. That's going to be my network. I can find ranges, but I don't need to do anymore. So my increment is 128, but I don't need anything else because I only need one network of 75 users. So my range is going to be from 50.1 to 50.126. So we have our first network with our mask. Let's go to the second biggest, 53. So for 53, we're going to do the same. Do I need 64? No, that's too much. So we need 32. So how many bits do I need to create the number 53? At least I'm going to need 6 bits. Okay, from 1, 2, 4, 8, 16, and 32, those are 6 bits. Now, I'm going to do the same process. I'm going to copy the default network mask. I forgot to mention about this. When we do VLSM, it's advisable to start from the biggest network and then go down to the smallest one. So 71 is our biggest, 53, 18, and then the ones that need only 2. So we have reserved the number, the host, and we're going to find our network, our new network mask, which is that 292, and I can find my increment, which is going to be the first one after the reservation. In this case, it's 64, and now I can find my increment. Well, I have my network 192.168.50.0/26, and we can continue to find the different ranges that we need. We only need one network. So the first one is going to be 192.168.50.0. The next one is going to be 192.168.50.64. However, something is happening here. I'm going to find the ranges, but if you notice the usable IP addresses, these two 0 and 64 are overlapping our last network, which is 50.0/25. You see that? So that doesn't make sense. That means we cannot use these two networks. That's the difference with VLSM from what we have been doing so far. So what we do, we go to the next network. You don't need to do this. It's just to show you how it works. In the future, you can do it. You can say, hey, 0 and 64 is already reserved. So we are going to continue to the next one. So the next network is going to be 128, and 128 is not being used by anybody. So that's the network we are going to use. So my ranges are going to be to 192.168.50.129 to 50.190. So this is the range I'm going to use. It's not overlapping anything. The network, the complete network I have to use 192.168.50.128/26. Let's go to the other network with 18 users. I'm going to do the same approach. I'm going to use the same approach. So 16, I need 16, 32, way too much. So to create the number 18, I'm going to need at least 5 bits. Now, what we are going to do here is the same that we have been doing. We're going to convert everything to binary. We're going to reserve 5 bits of host, starting from left to right, and the rest are going to be ones. Okay, with that, we can find our new network mask, which is going to be that 255, 255, 255, 224. Okay, so now I can find my increment, which is in the 4th octet as well, and it's going to be 32. We are not going to do the same as we did a few seconds ago. I know my next network is going to be 192.168.50.192. Okay, because our last user IP address in the last example is 50.190. 91 is going to be my broadcast, and 92 is going to be my next network ID. So having that in mind, we are going to find our ranges, which is going to be 192.168.50.193 to 192.168.50.222. So our final network, well, not a final network, the real network that we have to use is 192.168.50.192/27. Now let's go to the other 3. We need 3 more networks, which 2 host each. So how many bits do I need to create number 2? So I only need 2 bits, right? Now we are going to do the same. So to create number 2, I need 2 bits. I'm going to convert the default network mask for a class C to binary, and I'm going to reserve 2 bits, 2 host bits, starting from left to right. And the rest are going to become ones, as always, for host, when we are finding host. Now, my new network mask is going to be 255.255.255.252. And my increment is going to be in the 4th octet. It's going to be the first one after the reservation, and it has a value of 4. Now I can find my networks. Don't forget, I need 3, and I'm going to start from 224. Why? Because if you see the last example, for 18 users, our last user IP address is 222. So 223 is going to be the broadcast, and 224 is going to be the next usable network. So 192.168.50.224 is going to be my first network. Don't forget, I need 3. And I'm going to find the ranges from 50 to 225 to 50.226, only 2. Okay, so what are we going to do next? We have our next usable network, 50.228. We're going to do the same, the ranges, 229 to 230, only 2 IP addresses, usable IP addresses. And my last network is going to be 232. Have the ranges, 233, up to 234. So I have these networks, and now I'm going to assign them. You don't have to do it in any particular way. You can put anyone because they are the same size. So it doesn't make any difference how you distribute them. The point is the network 4, 6, and 5 need 2 hosts each. So with a mask of 30, you are going to have 2 usable IP addresses per network. That's perhaps the smallest network you're going to find in a real environment, or when you do some exercises like this one. So this is the kind of exercises you're going to find in a certification, Cisco, CCNA, or Network Plus, perhaps more Cisco. So that's technically it for VLSM, guys. It's really everything that we have been doing, with the exception that we have to check that the networks are not overlapping between each other. Finally, there is one more thing I want to talk about, which are exceptions or special cases. So you see these numbers 3, 7, 15, 31, 63, and 127. So binary is really good when we are trying to find even numbers, because it's based, well, on base 2. And but not really good to odd numbers. So we have the numbers here. I'm going to do the 2 examples to explain. So I'm going to do 31 now. 31 first. How many bits do I need to form the number 31? So 32 is going to be too big. 16, yes, that's what I need. So in order to create the number 31 in binary, we need at least 5 bits. So if we do some math to calculate the host, so we are going to have 2 to the power of 5 minus 2 is going to be equal to 32 minus 2, which is equal to 30. But 30 is less than 31. Okay, let's do one more. I'm going to do for 63. So how many bits do I need to create the number 63? 64 is going to be too much, so I'm going to go for 32. So to create the number 63 in binary, I'm going to need at least 6 bits. Now we are going to do the math again. So we have 2 to the power of 6 minus 2 is going to be equal to 64 minus 2, which is equal to 62. So again, we are one number short. And the problem is that since we subtract 2 numbers, the network ID and the broadcast address, and the broadcast IP address, we lose 2 numbers. So the rule here that I want you to take is that every time you're creating host, you're allocating host, always add a few numbers to the original number. Let's say you need 20 hosts. Why not 22 or 25? It's not going to change that much, the calculation, and you're going to end up with a few more hosts, available hosts. So another example, if you have, well, in this case 15, for example, and why don't you do for 20? Why don't you do for 18? So that's what I wanted to add here. These are some exceptions, some special cases where you can see that the math, the binary math, kind of, well, fails actually, because again, you subtract 2 numbers that we cannot use, the network, which are the network ID and the broadcast address. So technically, well, not technically, that's all you need to know about IPv4 subnetting. And the only thing left for you is to practice. So thank you very much for watching, guys, all these videos about subnetting in IPv4. And well, we have to start a new project. I really don't know what that's going to be now. So thank you for watching. If you haven't yet subscribed to the channel, I encourage you to do so. If you have any question, please leave it in the comment section below. Thank you very much. I'll see you in the next one.